Let's move on to perception. All right, so we started off with the difference between sensation and perception. So if you recall, sensation are the senses receiving information. Perception is the way that we interpret that sensory information. So we have the ideas here of visual illusions, right? So we've got the Ponzo illusion. Can you remember that one? Think of an escalator, think of parallel lines. We've got the Monocular illusion, where you have the arrows with the flaps pointing in different directions. We have Rubin's vase, where it is an ambiguous figure, so is our duck-rabbit illusion. And then we have the Ames room, which we experienced when we went to the Museum of Visual Illusions. Okay, so remember, this is all to do with misinterpreted depth cues, and what we are doing is fooling the mind, because we are used to a room being square. However, this of course is a trapezoid, and therefore it looks like people are getting taller or shorter as they move across the back of it. Okay, so from that we then moved on to think about visual cues and constancies, right? So we have monocular, which is using one eye, and binocular depth cues, which is using two. Our binocular depth cues are retinal disparity and convergence. Yes, so remember, when we're looking with one eye at our finger, and then we close our eye and we look with the other eye, and our finger seems to move. That's retinal disparity. And then as you move your finger closer towards you, that's convergence. Your muscles are working harder, so we know something is closer to us. Monocular depth cues, we have height in plane, relative size, occlusion, and linear perspective. Yeah, so when we look at pictures, even though something is smaller, because we know they are the same object, and we can see that one is higher up, we know that they are actually the same size. And we are comparing those relative sizes. Okay, we don't suddenly think, oh, well, that thing in the background is just much smaller, right? We know that these two things are a similar size. Occlusion is this idea that the thing that is behind is blocked out by the thing in front, so we again can tell a depth cue from that. And then linear perspective, so we're looking at lines that are parallel, appearing to get closer. So the further away something is, the more those lines converge. Right, I'm moving through. Then we looked at visual illusions. Okay, so we have to think about size constancy. So we know if we're sitting in a plane and we look down and we can see people moving about, they haven't suddenly become the size of ants. It's because they are further away. So we understand things by thinking about what we know about their size. Okay, we do have misinterpreted depth cues. Our brain will sometimes perceive distance when it's not actually there. So that's things like the Ponzo illusion and the Monocular illusion. And we also have ambiguity. All right, so obviously we know that you have your Rubik's cube, your duck rabbit and your Rubin's vase, sorry. Which are ambiguous figures. We've also got the Necker cube, yeah? Remember, where we can look at a cube and we can flip it so that the back wall becomes the front wall becomes the back wall, and so on. I'm doing it as I'm talking to you. And then finally we have fiction, which is Kinesis Triangle. Okay, and this is the idea that we can see something when it isn't actually there. Yep, so because the outline of what is there suggests something else, we actually start to see it with our eyes. All right, then we go on to Gibson's direct theory of perception. Okay, so here is the one from James Gibson, where he says we don't need any previous experience. Everything that is in our experience around us is helping us to understand and interpret what we're seeing. All right, so he talks about optic flow patterns. You know, when you're in a car and everything's going past you, you know that anything that stays stationary is that we're moving towards it. Okay, the things that are rushing away from us are moving past in the distance. Then he talks about motion parallax. This is another monocular depth cue. So those that are closer to us are moving faster, and those that are further away from us. He also talks about the influence of nature, that we learn to perceive things around us, and this is an innate ability. However, as you know, if you see me parallel parking, I have no innate ability to be able to have any depth perception. All right, we can evaluate this negatively in that that it doesn't explain things like visual illusions and us making perceptual errors, like me parallel parking. However, it does have a real world meaning with things to do with, you know, when you're in motion in a car, in a train, in a plane, whatever else. And it does also support the role of nature. Okay, so then to contrast that, we have Gregory's constructivist theory of perception, where Richard Gregory talks about this idea that we use all of the things that we know about the world to help us construct our perception, right? We don't have to guess what's out there because we can construct the world around us, right? So we are using things like inference. This has happened before, therefore I think that is going to happen again, right? It is furry and it barks, so I think it's a dog. Yep. And we will use visual cues to help us to get to that point. And because we are using previous experiences, then this is a nurture understanding, okay? It's not innate. We are building it up as we go along. All right, there are two negatives to this. The first is that Gregory, the last one actually in our books, is that Gregory doesn't actually explain where perception comes from in the first place. So how does it even get started? And then again with visual illusions, he still can't explain how comes they fool us, whatever else. However, there is support from research in different cultures. Okay, so remember when we've talked about the idea of looking at a building and seeing it going in certain ways, that's why we misinterpret the Monocular illusion. However, people who come from a culture where they don't have buildings around them wouldn't even think of it in that way. So we then looked at factors that affect perception. So the first one was culture. So we have a perceptual set, a way that we perceive things, and that comes from our culture. So Hudson did a study. He showed them the picture of the gazelle and the elephant and the hunter, and he asked them to explain what was going on. So the idea of interpreting 2D images was more likely the more able you are and the more educated you are. So this backs up Gregory's idea that perceptions are learnt as we go along. However, of course, this theory was criticised completely because he didn't do any cross-cultural research, didn't go across different cultures. And some of the participants might have been confused by seeing the 2D drawing in any case, and it was a very poor design in what he was actually doing in the test. Okay, so another factor affecting emotion, perception is going to be emotion. Okay, this is McGuinness's study. So it's the idea about things being emotionally neutral, or do they change the way that we see things? Okay, so if you recall, we saw some rude words in class where you all went and looked at me before you would repeat those words out loud. Okay, so emotion does play a big part in the way that we respond to certain situations. And McGuinness talks about perceptual defense. So when our brain is confronted with words that are offensive or cause embarrassment, we block out the information, even if it's just for a moment. All right, so there was an objective measurement in this study, but embarrassment is not a defense. Okay, you were all a little bit embarrassed, but eventually you overcame that, especially if I nodded and said, yeah, it's okay. But for some of you still, you wouldn't say that word because it's an embarrassment beyond saying it in front of me. It is also an embarrassment because of the way that you've been raised. There are contradictory results going on in here as well. So we might actually notice emotional material more if it has a positive emotional effect on us. And some people like things that make them sad. You know, why do we choose to watch a sad film if that's the case? You know, we know it's going to make us cry. Or why do we watch a scary film when we know it's going to scare us, but we still do these things? All right, we also then looked at motivation for affecting perception. And if you remember, this is Gilchrist and Nesberg's study, which is a named study. Is it on your case study sheet? All right, so this one is to do with food. Remember that people were shown food. So there was an experimental group of 26 undergraduates who went without food for 20 hours. And then there was a control group who weren't deprived. And then they were shown pictures of food. And then they switched off the projector and they were asked to adjust the lighting. And the results showed that the food-deprived participants made the lighting stronger and brighter, which led to the conclusion that hunger is a motivating factor that affects perception. Right? So if we are deprived of our basic needs, we will get a heightened sensitivity to things. Right? So this is why you don't go shopping when you're hungry, because food shopping, because you end up buying more of it. Right? So there is support from similar studies that back this up. Stanford deprived participants of food for varying lengths of times and then showed them ambiguous pictures. The longer the participant had been deprived of food, the more likely they were to perceive the pictures as representing food. Okay, there are obviously ethical issues here about depriving people of food and water. However, everybody did volunteer for it. And then another negative is that it's not like everyday life. However, we know that we get hungry in the case pace of a day. So it's not that unrealistic. Okay, then finally we have expectation as factors that affect our perception. Okay, so this is also a named case study. This is Brunner and Minton's study. So they were looking to see how much expectation is an important factor in perceptual set. So they had an ambiguous figure with A, B, C and 12, 13 and 14 going across and down. So those people who had been shown letters of the alphabet beforehand saw the ambiguous figure in the middle as a B, and those who had seen numbers beforehand saw the ambiguous figure in the middle as a 13. So expectation is an important influence on perceptual set, right? So if you remember, it's also things like when we see a sign that has a mistake in it, we don't necessarily see the mistake because we know what we think it's going to say. So our expectation just works it out for us in any case. All right, so this is an artificial task, so that's a negative. The study used an independent group design, which means there may be a problem of individual differences between groups, right? So we don't know the intelligence levels of the people, so it might have been a good idea to do paired groups and then swap them around. However, it does have a real-world application, so it does explain the errors that people might make. So the importance of context and expectation in perception help us understand and avoid errors of judgment. Okay, so that is perception, wow, even faster, in just under 15 minutes.